The next series of presentations are going to be with respect to the evidence that is used to support the theory of evolution, and it's going to be broken up into various parts. The note packet that you need, however, is the one seen off to the right. At several points, there's going to be some questions. Because this is not interactive for you, I will be the one doing the clicking. I will, on purpose, get questions wrong because you'll be learning from the most common misconceptions that are made anyway. I will make this presentation available to you as a PowerPoint if you have the ability to run a PowerPoint at home. Otherwise, that's why I turned this into a video. First question, why is it called the theory of evolution? The term theory is going to be something that you need to define the scientific definition of theory. Answer 1, it's been thoroughly tested many times by many people and has gained widespread acceptance, or it's not yet been proven well enough to satisfy most people. Which of those two do you think it is? I'm going to go with the wrong answer and tell you that no, the first one is correct. Theory has multiple meanings. Most people use it to mean a wild guess. And don't write anything. Because in previous years, that's what students have done. They've said a wild guess. Instead, please focus on the fact that it is not. In science, it is not a wild guess. In science, theory does not equal wild guess. Instead, they are testable hypotheses that explain observable data. A hypothesis that has been tested over and over and over again by a large group of people that end up with the same answer. So instead, a theory are hypotheses that were tested over and over by many groups of scientists who essentially got the same answer. Got the same answer. Here are some examples of theories. Atomic theory, that all matter is composed of atoms. The cell theory, where all living things are made of cells. Cells come from pre-existing cells, which we studied with mitosis. Theory of relativity, well, that's a physics concept, so you can wait on for that one. Plate tectonics, you've probably learned before with the shifting of the large land masses. And then the theory of gravity. If an idea becomes a theory, it is pretty much highly accepted. It's not considered to be a fact, though. Theories are not the same things as facts. Why? Well, although we're pretty certain that a theory is legit, if new evidence were to come along that would cause us, that would work against our theory, we would modify it. We accept the fact that it could be modified if new evidence were to arise. Whereas facts are usually the observations that we see and use as evidence to support those theories. Having a theory to be accepted, it's difficult. Because here is an example of where the geocentric theory, which if you look at the picture, the geocentric theory was that the Earth was in the center of the universe, and the sun and all the rest of the stars and planets moved around it. That was accepted for a long time. We know today that that's no good. Instead, the heliocentric model is that, and what do you accept as truth, is that the sun is in the center with the planets revolving around it. What made that change? Based on the level of technology and the knowledge that we had at the time. We might find out that our solar system isn't really arranged the way that we think it is with respect to the universe. The more and more technology that we develop might change our understanding of things. That's what a lot of science is. So now we get to this home page. The home page is taking the different aspects of evidences of evolution and breaking it up. And we are going to explore each of them. The fossil record is in fact where I'm going to start, but it is going to be in a separate video. So if you need to rewatch this component, feel free. Otherwise, move on to the next section.